Hello everybody and welcome to Stationeers. This is MacGyver and we're here on the moon for a solar tracking tutorial. So we're going to go over a few things today. The first is just building a solar array and having it automatically track the sun. Then we're going to go through and showcase a few different setups. And then finally we are going to get into how the daylight sensor works in relation to the solar panel. If you want to skip to a particular section, there will be timestamps on the screen. So let's get into it. Here are the materials that we are going to need for this build. We are going to need 5 glass sheets, 5 solar panels, a kit power controller, a large battery, a small one should work if you do not have a large battery, kit sensor. If you need to print one, I recommend printing it from the hydraulics printer. It's a little bit cheaper there. 4 kit logic IOs, 1 kit logic processor, 1 kit logic memory, 48 cable coil, and I'm using a light to represent the load, i.e. everything else that requires power. So let's collect these up and let's start building. So in this I'm going to be using the solar panel singles. So I'll go ahead and equip and let's start putting them down. So the single one, of course, has the port that is both data and power. The dual has separate data and power ports. So like I said, we're using the single, and I'm going to make it to where the ports are facing towards the east. And one more over here. Then we're going to grab the glass sheets and complete the solar panels. Okay. Next, I'm going to start throwing down some wire. And I'm just going to start here at the last solar panel, and I'm just going to work my way that way, worrying just about hooking up the solar panels at this point. So we're going to take these cables and just set them aside real quick. Next we're going to do the daylight sensor, and I'm going to place the daylight sensor to where the port is pointing towards the north. You always want to have the port of the daylight sensor counterclockwise 90 degrees from the port of the solar panel. It just makes things easier. Next I'm going to be doing the area power controller. Make sure it's going the right way. Now we got to start using tools. And I'm going to keep it off for now, and I'll turn it on when we're all set up. Okay. Now we're going to start placing down some of the logic chips. So we're going to start with the logic memory. Make sure it's pointed north and south, and just butt it right up next to the area power controller. And it actually doesn't matter whether it's this way or this way. It's down to visual preference, but best to keep it north and south in this build because it helps save space and resources. Okay. Next, I'm going to do the logic processor, and we're going to select the math unit. Set her down, power port to the east, the output to the west, and of course the in and outs north and south. Then the next thing we're going to do is the logic IOs. So we're going to start with a logic reader. Again, power port to the east, in to the north, and out to the south. Then we're going to do a batch writer, same setup as the logic reader. Then we're going to do a second batch writer, and then finally our second logic reader. And this is how we want the chips to all be laid out. Next we're going to lay down cable, and this time we're going to have the wire cutters in our tool inventory as well, because we got to splice into a few locations now. We don't actually have to have the wire cutters selected in our hand, we just need them in the other hand. So now we're going to start splicing into a few locations. The first one we're going to splice into is actually right here below the math unit. Next, we're going to go in between the first logic writer and then the first batch writer that we put down. Then right between the batch writers. And then the last place we're going to splice in is right before the second logic reader. Now we just hook up the data ports. Okay. Once you have all these data ports done, it's time to then run the power. So you can just start back here. So starting at the second logic reader, we'll start laying down the cable that's going to supply power to all these chips. When you're laying down these cables, it's important to make sure that they do not connect to any of the previous cables that we have put down. Otherwise, it will cause a short. And blown wires are not fun to deal with. Alrighty, at this point we'll go and throw down the light. And we want a big one. Bigger. There we go. Nice big light. Big and blue. Now that it is all wired up, we now got to label things. So now we're going to start labeling all of the logic readers and batch writers. We're going to start with the second one that we placed down, and we're going to work on down the line. Turn on the labeler. So we are going to put horizontal at the end, so then we know that this one is going to be working with the horizontal values. Confirm. Alrighty, come to the batch writer. And again, horizontal. If you want to name it something else, by all means. This batch writer we're going to name vertical. And then last but not least, this logic reader is going to be vertical. And we shouldn't have to name anything else after that. Next we use the screwdriver and we start programming. So again, we're going to start down here at the second logic reader that we have named horizontal. For the in value, we are going to say the daylight sensor. Oops. Too far. There we go. Its variable is going to be horizontal. Okay. And then we're just going to say on. For the batch writer, we want the logic reader horizontal. The out type is going to be the solar panel single. And then for the out variable, we're going to want the horizontal. Turn it on. So the horizontal is now set. Don't have to do anything else with it. We're actually going to skip over this batch writer. We're going to be coming right back to it. And we're actually going to go to this logic reader. And we're going to start doing the same except vertical. N was going to be the daylight sensor. The variable is going to be the vertical. Turn it on. This is where it's going to get a little bit different. Okay, we got two inputs on this. Input 1 is going to be the logic reader vertical. Input 2 is going to be the memory. And the output is going to be add. The default to add, so we actually don't have to change that. Turn it on. Then on the memory, we're going to come here and we're going to put in a total of 90. So logic memory 90. So what this is going to do is it's going to take whatever the daylight sensor is saying for the vertical angle, add 90 to it, and it's going to shoot it out. Now we come back to the batch writer, and we want the math unit, logic math. Out is going to go to the solar panels again. The variable is going to be the vertical. Logic math. Oh, wait. There we go. Double check to make sure everything is selected correctly, because if you don't, this will not work. Vertical, on. Alrighty. So, in theory, this is all set and ready to go. To see if it's working, all these solar panels are pointed that way. So if we turn this on, these solar panels should point in the same direction. And it looks like they are. So it looks like it's done correctly. We have no flashing lights. Then all I have to do is wait until sunup. Oh. And as you can see, sun has passed midnight. So the solar panels are now correcting to sunrise. We're going to close up the area power controller. And, well, when we see this light turn to flashing green in the morning, we'll know it's correct. And welcome to the morning. As you can see, we now have a solid green light on our area power controller. The solar panels are tracking, the sun is coming up, and as the wattage increases, you're also seeing that the efficiency is increasing. I say it's a success. We got light. Next, we're going to go over a few of these displays that I have set up so you can actually see what is actually needed for it to work, and so that then you can figure out how to manipulate this stuff to suit your own design. So here is, in a sense, the same setup that we just built. However, I've expanded it out and I used the solar panel dual instead of the single to separate out the power and the data so you can see exactly where you need to have power and where all what you need is data. This display and the next two displays are set up to where red is power, green is data, yellow is both. And in this display, you can see that we only have green and red. So data and power is completely separated in this. They do not mix at all. All the power coming from the solar panels is coming down these wires right here into the area power controller. Here is basically our representation of load, aka your base. And of course then it supplies power to the chips that require it. as you can see from this view, you have the data being split between the two logic readers. We have the horizontal on top and then the vertical on bottom. The daylight sensor in this example is set up just like in the build example that we just did, with the data port to the north. And with these solar panels, there with being the dual, you have the data port going to the west and the power port going to the east. We'll dive into more of why that is later. So if you follow the green wire from the daylight sensor, you'll see that it splits and it goes to both the logic readers. The logic reader on top is of course getting the horizontal value, the one on bottom is getting the vertical. And just like in the build that we just did, the logic reader then just goes straight to the batch writer with the horizontal value, and the batch writer just goes out to all the solar panels. The vertical logic reader on the bottom sends it to a math unit, which then adds the 90 from the memory unit, sends it to the batch writer, and then that goes out. In this example, we have gone from the logic chips to the IC chip, where you can program in basically all the functions of the logic chips, but in a nice little package. As you can see, we have power coming in one side, as the previous example, and all the data going out the other. It is completely separate, and as in that example, as you can see, the daylight sensor does not require power. It is strictly data. This right here is what I like to call the fully fluffed code for making a solar alignment script. You have the alias of the daylight sensor at pin D0. You have the azimuth or horizontal using registry 0. The elevation or vertical using registry 1. The azimuth offset is 0, because in this example, the data port of the daylight sensor is negative 90 degrees from the power port of the solar panel, so the offset stays at 0. The elevation or vertical offset is at 90, because in the previous two examples, that's what we used. We added 90. And then here I have the prefab hash for the solar panel dual and the prefab hash for the solar panel single. Here's the actual start of the actual code that is going to be ran through. I like to put yield at the start. You can put it at the end or leave it out altogether. Here on line 9, we are loading the horizontal value from the daylight sensor into registry 0 or azimuth, adding the offset, and then we are saving it to all the solar panels. Line 12, we are loading the vertical value from the daylight sensor into elevation or R1, adding the offset, and then saving it to all the solar panels. Then we're just jumping back to the start. Like I said, this is what I like to call the fully fluffed code, because I don't know how to make this code any bigger and still keeping it basic. And here's my third setup of a solar panel array. This uses the IC chip as the last display did, but instead of using the solar panel duals, this uses the solar panel singles. As you can see, the wire is yellow because on that wire we have both all the data and power running through it. And we have it isolated by the area power controller and the IC10 housing. So down here we have strictly power going out to the base and back to the IC10 housing, and it's only data coming out of the IC10 housing. And again, like the build and the prior two examples, the data port of the daylight sensor is negative 90 degrees to the power port of the solar panel. This version of the solar script is the completely defluffed version. There is no aliases, no definitions. This is strictly what's needed for it to run, and that is it. We have the yield here at the very start of the code, so the code pauses there every time instead of every 128 lines. This code is set up slightly differently, to where the daylight sensor is actually not assigned to a pin on the IC10 housing. We're actually doing a load batch command, and this right here is the prefab hash for the daylight sensor, and we were pulling the horizontal value from it. And this little 0 at the end is the load batch mode. 0 means average, and the average of 1 is 1. And that is all being stored into registry 0. Because the daylight sensor is at -90 from the power port of the solar panel, we don't have to adjust the numbers. On this one, we're saving to the solar panels. This is, of course, the prefab hash for the solar panel single. The horizontal value is what we're saving it as. And, of course, we're pulling it from registry 0. Because at this point, registry 0 is no longer needed for the horizontal, I'm just recycling it and using it for the vertical. And I'm doing the same thing. Load batch into R0, daylight sensor, vertical, average. Here we have to add the 90, otherwise it will not work correctly. So add into registry 0, R0 plus 90. Save batch to the solar panel single vertical value from registry 0, and we just jump to line 0. This is the absolute minimum code and minimum things that you got to do in order to make this work with as little complications as possible. Because with this, you don't even have to program in a pin. You just load it to the chip, turn on the housing, and let her go. Throughout this entire video, I have been emphasizing that the data port of the daylight sensor needs to be at -90 degrees from the power port of the solar panel. This display will then show you why. As you can see, I have each of the daylight sensors labeled, and I have a dial here that allows me to switch to where the chip here will read from one of these daylight sensors, and the little LED display here will let us know which sensor it is getting its readings from, and then it's just blasting it out to all 4 of these solar panels. Right now, as you can see, the display says 0. So 0 is the north one, which is this sensor. And as you can see, this solar panel is the only one that's actually pointing towards the sun. The others are off by either 90 degrees, 180 degrees, or 270 degrees. And if we come and just change this to where now it's reading from this sensor, all the solar panels are realigning. And now you can see this daylight sensor has its port pointing towards the east, and the only panel that's correctly aligned is this one with its power point pointed towards the south. Again, the -90 degrees. And of course, as we go through, number 2, same thing. Data port to the south, the only panel that's aligned, data power port to the west. Then last, sensor 3, data port to the west, and the only solar panel aligned, power port to the north. So if you're going to have it set to where your sensor is not going to be at a -90 degrees from the solar panel's power port, you have to put in an offset of either 90, 180, or 270. Otherwise, your solar panel will not line up. Now, in doing all this, it did make me wonder, is there actually a position that you could put the daylight sensor to where you don't have to put in an offset at all? Well, unfortunately, no. However, there's 2 positions that do appear promising. Because if we come over here to this one, As you can see, this one's actually pointing at the sun, and it's 100% efficiency. And if we come through all of this down here to this one, it also too seems to be working. Okay, the difference is this one has the port. On all these solar panels, the power point is pointing towards the east, and on this display, the daylight sensor has its data port pointing towards the north, and its face pointing towards the west. While this one, the data port is of course pointing towards the north. However, its face is pointing towards the east. And it does look like it works. But unfortunately, it only works on the moon because the moon has a solar angle of 0. I went ahead and did a little creative on minus. So you can see these two solar panels right here, the information they're getting is being fed directly from the daylight sensor. It's just, here's what the IC chip is just reading what the daylight sensor is saying, and it's just shoving it right back into the solar panel, no offsets. And as you see, one of them kind of points towards the sun, but not really. And the other one, yeah, it's missing. But if you have the daylight sensor at a negative 90 degrees to the port, and just put in the offset for the vertical, you still get almost 100% efficiency, 99. And being minus, solar panel's not very good here, only 88 watts. If you found this video informative, please hit the like and subscribe buttons. If you want to be updated when another video is posted, click that bell notification. And until next time, good luck, have fun, and enjoy the rest of your day. Bye.